Hello students, today I am going to discuss the distance time graph and velocity time graph, and with the help of graph we will find the speed, velocity and displacement. So first of all I will discuss how to calculate the speed from the distance time graph. So look at the graph very carefully. In time t1 second, the distance covered by the body is x1, and in time t2 second the distance covered is x2. So in the time interval t2 minus t1, the body covers a distance of x2 minus x1. Okay, speed equal to distance by time. So putting the value of distance, that is x2 minus x1, and time t2 minus t1. So x2 minus x1 is replaced by bc, and t2 minus t1 is replaced by ac. This ratio is the slope of the given time graph. This is the required line, and this is the slope, that is inclination of this line with the horizontal, which is also known as tan theta, and the ratio of tan theta in trigonometry is perpendicular by base. So this is the slope. So finally we are getting speed equal to slope of st graph. So we can say that if we want to find the speed using distance time graph, we can find the slope of the distance time graph. It will give us the speed. Now velocity time graph. First of all I will draw velocity time graph for uniform acceleration. So I have taken the origin O, and all measurements are taken from O. So the initial velocity of the body is 0. That is why the body starts from this point. When the uniform acceleration, then it will be a straight line because velocity increases at uniform rate. For non-uniform acceleration, in which velocity increases at non-uniform rate, so it is a curved line. I have drawn over here. For uniform retardation, in uniform retardation the velocity of the body decreases at uniform rate. So velocity is decreasing, time is increasing, but the velocity is decreasing. So it is a straight line. And for non-uniform retardation, it will be a curved line. You just look at here, it is a curved line. So all the graphs I have drawn. Now I am going to plot VT graph from the given data. So data is given, you go through the data. Velocity is given in meter per second, time is given in second. Before plotting a graph, we must select a proper scale. So I have chosen along x-axis 1 centimeter represents 10 second, and along y-axis 1 centimeter represents 10 meter per second. Now we are going to plot. So all the data, that is along x-axis and along y-axis, have been written over here, and there will be 5 dots. When we join all these dots, we are getting a straight line. So we can say that the nature of motion is uniform. That is, this graph represents the uniform acceleration. Now calculation of displacement using VT graph. How can we calculate the displacement using VT graph? So look at the graph. This is the line AB represents the constant velocity, and we know that displacement equal to velocity into time. So the total time we can consider over here like OC. OC is the total time, and in total time the velocity of the body is CB, and CV is equal to OA because these two lines are parallel. So displacement replaced by S equal to BC into OC, and putting the value of BC equal to OA into OC, and we see that OA into OC is the area of rectangle OABC. So what do you understand? displacement equal to area of rectangle OABC. This gives an idea that whenever we want to find the displacement using VT graph, we simply calculate the area under the VT graph. Okay, so when we calculate the area under VT graph, then it gives us displacement. I think it is clear to you. Now, velocity time graph for uniformly accelerated motion, when the initial velocity of the body is 0 and when the initial velocity of the body is not 0. So first you see the graph when initial velocity is 0. When initial velocity of the body is 0, then body will start from the origin, that is reference point. Okay, and it will be a straight line, and when the initial velocity of the body is not 0, in that case the graph takes the shape in this way. The body has some initial velocity which is represented by this line, and the body now starts accelerating from point A. The body starts accelerating uniformly from point A, and during A to B the acceleration of the body is uniform because its velocity increases at uniform rate. So this was the two graph that gives an idea how to draw the velocity time graph when initial velocity of the body is 0 and when the initial velocity of the body is not 0. You can see once again how to draw these two graphs. Okay, now we want to calculate the acceleration using velocity time graph. Look at the graph carefully. In this graph you can see the initial velocity of the body is represented by line OA, which is initial velocity u, and after some time, let it be t1, the velocity becomes v1, and after time t2 the velocity of the body becomes v2. So in the time interval t2 minus t1, what is the velocity? Change in velocity is v2 minus v1. Now we know that acceleration equal to change in velocity divided by change in time. So change in velocity in the given time interval is v2 minus v1 divided by t2 minus t1. Now you look at the graph very carefully. v2 minus v1 is replaced by line CD and t2 minus t1 is replaced by line BD. So this is the required ratio, and we see that v2 minus v1 is equal to CD and t2 minus t1 is equal to BD. So CD by BD is the slope of line BC. So once again we have come to the slope. So in this VT graph, if we calculate the slope of VT graph, we can calculate the acceleration, or we can say that acceleration equal to slope of the line BC. Now using velocity time graph, or we can say that equation of motion by graphical method. Now we are going to prove three equations of motion, starting from first equation, that is v equal to u plus at. Okay, so you go through the graph very carefully. This is the VT graph, that is velocity time graph, in which the initial velocity of the body is OA, which is represented by u, and after time t the velocity, final velocity of the body becomes v, represented by line this is the line dv, and dv equal to v. So we know that acceleration equal to slope of line. In the previous graph, in the previous VT graph, already calculated acceleration equal to slope of VT graph. So acceleration equal to slope of line AB, we can simply write BC by AC. So whenever we want to write the slope of line, anywhere you can write perpendicular by, you can take the ratio perpendicular by base. So slope of line AB is BC by AC, and BC is replaced by BD minus DC, and AC is replaced by OD because AC equal to OD. Now putting the value BD minus OA, BD equal to V and OA equal to U, V minus U by T, or V equal to U plus AT. So what to do in this derivation? We simply write acceleration equal to slope of line. We utilize the concept of acceleration, how to find the acceleration using VT graph, that has been utilized over here. Now second equation is S equal to UT plus half AT square. So S equal to UT plus half AT square means S is displacement, U is initial velocity, A acceleration, T time. So how to prove it? We already know that in VT graph we can calculate the displacement, and displacement equal to area of VT graph. So taking this concept, we can write displacement equal to area of trapezium OA BDO, and this area of trapezium has been divided into two parts. First part, area of rectangle OACD. OABCDO is divided into two parts, that is area of rectangle OACD and area of triangle ACB. So putting the value of area of rectangle OACD and area of triangle ABCD, which is UT plus half T into V minus U, because BC has been replaced by BD minus CD, which is V minus U. Okay. Now further, V minus U is replaced by AT. From first equation we can write the value of AT. From first equation, V equal to U plus AT. So V minus U equal to AT. After replacing and calculating, we get the displacement equal to UT plus half AT square. Now the third equation, B square equal to U square plus 2AS. Once again we can write displacement equal to area under VT graph, and area under VT graph in this case is replaced by area of trapezium OABDO. So area of trapezium is replaced by sum of two parallel sides into height divided by 2, and now we put the value of sum of two parallel sides, that is OA and DB. So OA plus BD into OD by 2. Now putting the value and replacing T from first equation, T equal to V minus U by A. So finally we are getting V square minus U square by 2A, or V square equal to U square plus 2AS. So this was the graphical method to derive the equation of motion. Once again you go through the graph and try to understand. In first graph, acceleration equal to slope of line has been used. In second graph, displacement equal to area of trapezium has been used, because we know that in VT graph displacement is written as displacement equal to area under VT graph. In third equation also displacement equal to area under VT graph. Now you go through all these derivations and try to understand. If you have doubt, you may write your comment in the comment box. I will give the answer. Until then, enjoy with physics. Thank you very much.